All right, and we will get some factoring practice in, and specifically we'll do some examples with factoring by grouping. So this is find the zeros of the following quadratic functions, and we will solve them by factoring. So here I have 4x squared plus 7x. Now when I have my standard form of a quadratic, ax squared plus bx plus c, I can see here in this example that I'm missing the c term, so it looks like both of my terms have an x in common. So what I'm going to do is factor out an x. Then I'm left with 4x plus 7 is equal to 0. I can use the zero product property, and if these two pieces are being multiplied together and they equal 0, I know that at any time each piece could equal 0. So I have x is equal to 0, or 4x plus 7 is equal to 0. So I have x is equal to 0 as one of my answers, and I can go ahead and keep solving. And x is equal to negative 7/4 is another one of my answers here for this quadratic. Moving forward by solving for the zeros, or again, zeros are roots, zeros, and x-intercepts are all interchangeable terminology that we'll use here. 2x squared plus 3 is equal to 5x. I know in order to find these zeros, I first need to set the equation equal to 0. So if I were to set this equal to 0, I would have minus 5x plus 3 is equal to 0. And I'll go ahead and I'll solve this by factoring, and specifically factoring by grouping. So when I factor by grouping, the first piece that I need to do is multiply my a and my c together, and this will give me 6. This 2 times 3 gives me 6. Then I need to think of two values that multiply to 6 that will add up to my middle value here, which is negative 5, or my b term, I could call it. So thinking about values that multiply to give me positive 6, I have 1 and 6, and I have 2 and 3. And neither of those values will add up to negative 5. But what will add up to negative 5 is negative 2 and negative 3, and those two values also will multiply to positive 6. So now I can rewrite my function here, 2x, but instead of writing this negative 5x here, I'll write using my values that I chose up here. So minus 3x plus 3 is equal to 0. So you can see that I haven't changed what my original equation is. All I did was, instead of writing negative 5x, I wrote negative 2x plus negative 3x. So now this is factoring by grouping, so I'm going to go ahead and group my first two terms and my last two terms. And looking here and here, I can see that this first set of parentheses, both of those terms share a 2x, and I'm left with x minus 1. And I can see this second set of parentheses up here, both of those share a 3, but because my first piece here is negative, I'm going to pull out a negative 3. So now I can see that both of these values, or both of these sort of terms, if I'm looking at these terms on the grand scheme of things, both of these terms have x minus 1 in common. So I'm going to pull out that x minus 1, and I'm left with 2x minus 3 is equal to 0. And now I've factored this quadratic. So I can again go ahead and use my zero product property and set each of those pieces equal to 0. So x minus 1 is equal to 0, which means that x is equal to 1. And 2x minus 3 is equal to 0, which means that x is equal to 3/2. So we'll do one more example. And I have this last example for us here. 0 is equal to 5z squared plus 7z plus 2. And I'll go ahead and solve this by factoring, and specifically factoring by grouping. So I will multiply my A and my C together, and that gives me 10. Thinking of values that multiply to give me 10, I have 1 and 10, and I have 2 and 5. And it looks like 2 and 5 will be the pieces that add up to this 7 right here. So I'll go ahead and rewrite my equation. So 5z squared plus 5z plus 2z plus 2 is equal to 0. So again, I haven't changed what my actual equation is. I've just expanded it a little bit. And going back to factoring by grouping, I'll group the first two terms and the last two terms. What do each of these pieces have in common? They have a 5z, and I'm left with z plus 1. And each of these pieces have a 2 in common, so I'm left with z plus 1 again. And I can see here that both of these pieces have a z plus 1 in common. So I'll go ahead and pull that out, and I'm left with 5z plus 2 is equal to 0. So my zero product property tells me that I can set both of these pieces equal to 0. So z is equal to -1, and z is equal to -2/5. And this is my final answer for finding those x-intercepts using factoring by grouping.